Somewhere in rural Kentucky, there is a woman named Dorothy whose kitchen counter tells two stories at once. On the left sits a stand mixer her late husband bought her as a wedding gift in 1974. Avocado green, dented on one side from the time it fell off the counter during a thunderstorm. Still runs, still kneads, still makes the same honey wheat loaves it has been making every Sunday for 50 years. Dorothy has never had it repaired. She has never called a technician. She has never had to. On the right sits the replacement she bought 14 months ago, when her daughter convinced her the old one deserved retirement. Brushed chrome, digital speed display, a little LED ring that glows blue when it's running. She paid $420 for it at a department store. She used it 11 times. On the 12th use, it started making a sound she described to her daughter as like gravel inside a tin can. 3 weeks later, white powder began collecting around the base of the beater shaft. A repair technician quoted her $190 to fix it. The mixer cost $420. Dorothy put the new one in the garage and moved the avocado green one back to the center of the counter. This is not a story about one unlucky woman in Kentucky. This is a story about what happened to American manufacturing when accountants were handed the keys to the engineering department. What changed and when? To understand why Dorothy's 1974 mixer refuses to die while her 2023 model is already in the garage, you have to understand who built each one and what they were optimizing for. In the mid-20th century, the company behind the machines that would eventually become household stand mixers was primarily in the business of feeding armies, hospitals, and cities. Their clients were commercial bakeries that processed thousands of loaves per day, university dining halls that never closed, naval ship galleys that needed equipment to survive salt water and rough seas. These were customers who could not afford downtime. A broken machine in a hospital kitchen at 5 a.m. was not an inconvenience. It was a crisis. So the engineers built accordingly. Everything was overspecified. Motors wound tighter than necessary. Gears cut from steel when aluminum would have technically sufficed. Housings cast from metal when plastic could have held the shape. And the logic was simple. The cost of a field failure, a broken machine in the hands of a paying commercial client, was far more expensive than the cost of using better materials at the factory. Reputation was the product. The machine was just proof of it. When that engineering culture produced a home consumer version, it brought its entire philosophy with it. Your grandmother's mixer was, in almost every meaningful sense, a scaled-down commercial appliance. She paid for something built to the standards of a professional kitchen, and she got exactly that. Then, ownership changed hands. The acquiring company was not in the business of building things that lasted forever. They were in the business of building things that sold consistently, and those are very different businesses. A product that lasts 50 years generates one sale per household per half-century. That is an engineering achievement and a financial disaster. A product that lasts 7 years generates 7 or 8 sales per household across the same time span. The math is not complicated, so the machines changed. Not overnight, not in ways that were obvious to the eye. The silhouette stayed the same. The color options expanded. The marketing grew warmer and more nostalgic, leaning heavily on imagery of grandmothers and heirloom recipes and the idea of a machine passed from mother to daughter across generations, even as the actual machines became progressively less capable of surviving across generations. The gear they hope you never find. Inside every modern tilt-head stand mixer in this price category, and behind the iconic metal shell and beneath the reassuring weight of the body, there is a gear made of nylon. It is roughly the size of a $50. It costs the manufacturer somewhere between $2 and $4 to produce. And it is the single component most responsible for the wave of failed machines showing up in repair forums, estate sales, and landfills across the country. The official explanation is that this component serves a protective function. When the machine is overloaded with heavy dough, the nylon gear is designed to fail first, to sacrifice itself before the motor burns out. Think of it as a fuse, the company says, a cheap, replaceable part standing between you and an expensive motor failure. This explanation is not technically wrong. It is, however, profoundly incomplete. See, the machines these products replaced, the ones built under the previous engineering philosophy, did not need a sacrificial gear because they handled overload differently. The motor itself contained thermal protection circuitry. Push the machine too hard, and the motor would simply shut itself off, cool down, and resume. Nothing was destroyed. Nothing needed replacing. The machine recognized its limits and managed them internally. The sacrificial gear does something different. It does not manage overload. It converts overload into a transaction. Strip the gear through normal use, and it does strip through normal use, not just abuse, as thousands of owners have discovered. And you now have two options. Pay a technician between $80 and $150 to open the machine and install a new one. Or decide the repair cost is not justifiable on a machine that costs $350 to begin with, and buy a replacement. The company profits either way. The gear is not a fuse. It is a business model. The oil problem nobody warned you about. There is a second issue that receives far less attention than the gear failures, possibly because it is stranger and harder to photograph dramatically. But it affects far more users. Every stand mixer of this type leaves the factory filled with lubricating grease. This grease is supposed to be a permanent solution, applied once, sealed inside the gearbox, lasting the life of the machine. The word lifetime appears in the documentation. What actually happens, particularly in machines that are not used on a regular schedule, is that the grease separates. The oil component migrates out of the compound. It works its way down through the mechanism and eventually exits the machine through the beater shaft, the vertical rod that holds your whisk or dough hook directly over your mixing bowl. If you have ever noticed dark droplets or a brownish film appearing in your batter before you add anything, this is likely the source. Machine lubricant, dripping from the gearbox into your food. This is not a rare manufacturing defect. It is common enough that the company maintains official guidance on the matter. Their recommended prevention: run the mixer on high speed for approximately 2 minutes at regular intervals, even when you have no actual mixing to do, to keep the grease in suspension. Your grandmother never did this. Her mixer sat in the cabinet for weeks between uses and never once dripped anything into her food. So the grease in that era's machines was formulated differently, more stable, less prone to separation, more expensive to produce. The reformulation that introduced the separation problem corresponded to a reduction in material costs and an increase in quarterly margins. The machine became cheaper to manufacture. It became more demanding to own. The burden of maintenance shifted from the engineering department to the customer's kitchen counter. The fine print that should make you angry. At some point, you might decide to test your new stand mixer by using it the way mixers have been used for a century, to knead bread dough. You might pull out a recipe that calls for 10 to 12 minutes of mechanical kneading at medium speed. You might run the machine for the duration the recipe specifies. If you do this, you are, according to the manufacturer's own documentation, using the product incorrectly. The official guidance specifies that dough kneading should occur only at the lowest speed setting, only in intervals no longer than 2 minutes, with the total mixing and kneading time not exceeding 4 to 6 minutes per batch. Exceed these limits, and you may void the warranty. The machine is not rated for the task that is printed on every bread recipe ever written. Think about what this means. The marketing shows bread. The lifestyle imagery features flour-dusted bakers pulling gorgeous loaves from their ovens. The word artisan appears prominently. And the fine print, buried in a manual most buyers never fully read, quietly disqualifies the machine from doing the thing the marketing implied it was designed to do. And Dorothy's 1974 mixer has no such limitation printed anywhere, because the engineers who built it never imagined they needed to protect the machine from bread. What you can actually do. The vintage market for pre-ownership change stand mixers is more robust than the industry would prefer you to know. Online resale platforms regularly list machines from the 1960s, 1970s, and early 1980s. 40- and 50-year-old appliances in functional condition, often for less than $200. A professional cleaning and re-greasing runs between $40 and $75 at most appliance repair shops. For $250 total, you acquire a machine built to commercial-grade standards that will likely outlast anything currently sitting in a showroom. The components are, paradoxically, easier to source than parts for many modern machines. The older designs used standardized, widely available bearings and mechanical components. The newer machines increasingly use proprietary parts obtainable only through the manufacturer, a design choice that ensures repair dependency rather than repair accessibility. For buyers who prefer something new, the European market never entirely abandoned the philosophy of building appliances to last. Certain Scandinavian manufacturers, in particular, still produce machines using fully metal construction, continuous duty motors, and no sacrificial components. These machines cost significantly more at purchase. Over a 20-year period, accounting for replacement costs and repair bills, they cost significantly less. The name is not the machine.